Good day. So today, we'll look at some examples dun sa topic natin na area between two curves. And I hope that you pause the video and give yourself a chance to answer these exercises on your own first before proceeding dito sa video na to. And then let's just compare our solutions. So for the first problem, you're asked to find the area of the region bounded by these two curves, y equals x squared, tsaka y equals negative x squared plus 4x. So ito yung graph ng dalawang curves. Let's label them. The graph that's color blue, this is the graph of y equals x squared. And yung plot na kulay green, this is the plot of the function y equals negative x squared plus 4x. Now, you will notice merong region na parang slightly pinkish. Ito yung region na bounded by these two curves at yung area niya, yung gusto nating mahanap ngayon. Now, yung topic natin will be using vertical strips. So, ang gagamitin nating approximating rectangle para pag-compute ng area niya sa Riemann sum will be this rectangle. Let's say that is the ith subinterval and that is the ith rectangle. Yan yung magiging portion na gagamitin natin na pang-approximate nung area natin. And I'm drawing this, para makita lang natin or para ma-highlight lang natin kung ano yung function na nasa taas at ano yung function na nasa baba. For this subinterval, of course, we are using si x sub I kasi ang assumption natin, this is the ith rectangle, to get the upper and the lower values. And in this case, yung upper value natin, i-designate natin siyang f, at yung lower value natin, siya i-designate natin g. So this would mean that our f of x will be c negative x squared plus 4x at c g of x will be c x squared. Okay, so f of x is equal to negative x squared plus 4x and g of x equal to x squared. Kasi si negative x squared plus 4x, siya yung upper function dun sa interval na kukuhanan natin ng area. And si g of x, siya yung lower function in that same interval. Now, ano ba yung interval na i-compute natin? So, we need to solve for the limits of integration. Kaya kailangan nating malaman yung bounds ng interval. And if you take a look at the graph, then that would be yung x values ng intersection points ng dalawang graphs. So, we'll use simultaneous equations to solve for the value of x. So, since y equals x squared dun sa isang function at y equals negative x squared dun sa other function, i-equate natin yung y values nila and solve for the x value na magiging equal yung y. That's how we find the intersection, diba, of two curves. So solving this is x squared equals negative x squared plus 4x, or this can be rewritten as 2x squared minus 4x equals 0. Factoring out si 2x will get x is equal to 0 or x is equal to 2. So dalawang x values natin, ito yung x values ng points of intersection. And then yung ating interval, kung saan tayo mag-integrate, will be bounded by 0 and 2. So we could now set up the integral using what we learned from the previous video. We could write this now as the definite integral from 0 to 2 of f of x minus g of x. Pero sinubstitute na natin si f of x as negative x squared plus 4x at si g of x as x squared. So simplifying the expression, this is the definite integral from 0 to 2 of negative 2x squared plus 4x. Applying the power rule, para makakuha tayo ng isang antiderivative, we'll get negative 2x cubed over 3 plus 4x squared over 2. This is an antiderivative of negative 2x squared plus 4x. And we'll get, well, ano bang ginawa ko muna? Sinimplify ko muna yung 4 over 2. So we'll substitute 2 dun sa x. We'll get negative 2 times 8 over 3 plus 2 times 4 minus 0 na yung remaining expression. Kasi pag sinubstitute natin yung 0, mag-0 lahat ng fractions. And simplifying this, we'll get our answer to be 8/3. And since we're looking for the area, this is 8/3 square units. So let's box this to highlight that that is our final answer. Let's move on sa next problem. For the second problem, again, we want to find the area of the region bounded by a set of functions, curves, and equations. So in this case, we're looking for the region bounded by y equals sine x, y equals cosine x, and the two vertical lines na x equals 0 and x equals pi over 2. So since given na sa atin yung x equals 0 and x equals pi over 2, ito yung atin na ring limits of integration. Ito yung interval kung saan tayo mag-i-integrate. So let's take a look at the graph. So first, we need to identify alin dyan yung sine x, alin dyan yung cosine x. I think it should be easy for us to identify na yung 1 pag x equals 0 siya yung cosine, and yung green kasi 0 siya pag 0 yung x, siya si y equals sine x. And we are looking at these two shaded regions. Yan yung ano nila, yan yung region bounded by the two functions x equals 0 and x equals 2. You will notice that we could separate this into two regions. I'll call them A1 and A2 for region of area 1 and region of area 2. Sa region 1, sa region of area 1, yung upper function natin is y equals cosine x. Pero dun sa second region natin, nagpapalit sila ng position and our upper function is y equals sine x. So this would mean that we would have to write two separate integrals. Para consistent yung solution natin, let's again draw an approximating rectangle and let this rectangle represent the ith subinterval. So we could get an x value, we'll call it x sub I, para kunin yung y values nung taas ng rectangle at yung baba ng rectangle. Kasi we need those two y values para kunin yung height niya. So at x sub I, yung point sa taas ng rectangle, this will be evaluated at x sub I, cosine x sub I. And yung point dun sa lower side nung rectangle natin, yung nag-intersect dun sa green na curve sa sine x, that will be given by x sub I, sine x sub I. And here we can see na that in the jth subinterval na nandun sa second region, we have another approximating rectangle na yung height niya will be given by the difference nung y value ng isang point sa taas ng rectangle at yung y value ng isang point sa baba. And here, I hope we could see that the upper function is nag-switch na. It's now sine x. And the y value will be given by sine xj. And yung y value nung base naman nung rectangle will be given by cosine xj. So baliktad siya nung nung sa first region. So in the closed interval 0 to pi over 4, kasi nasa gitna nung 0 and pi over 2 yung pi over 4, the upper function is y equals cosine x. While in the other subinterval, dun sa pi over 4 papuntang pi over 2, yung upper function ay y equals sine x. So, isulat lang natin yung observation natin kanina. Now, the area of the first region will be given by the definite integral from 0 to pi over 4 nung upper minus lower, so cosine minus sine x. And now, for the second region, yung area naman niya will be given by the definite integral from pi over 4 to pi over 2 ng upper minus lower, but in this case, yung upper natin, y equals sine x na. Tapos yung lower, y equals cosine x. So, nagpalit yung dalawang terms, yung sine tsaka yung cosine. Let's solve first for the first area. So, an antiderivative of cosine x minus sine x will be sine x plus cosine x. We'll apply FTC2 and evaluate it from 0 to pi over 4, and we'll get sine pi over 4 plus cosine pi over 4 minus sine 0 plus cosine 0. Syempre, naka-quantity. This will give us square root of 2 over 2 plus square root of 2 over 2 minus 0 plus 1. Okay? And that's equal to square root of 2 minus 1. Now, on dun sa second region, sa right side naman natin. And an antiderivative of sine x minus cosine x will be negative cosine x minus sine x. We'll evaluate this from pi over 4 to pi over 2. This will give us negative cosine pi over 2 minus sine pi over 2 minus negative cosine pi over 4 minus sine pi over 4. And evaluating this, we'll get 0 minus 1 for the first group minus negative square root of 2 over 2 minus square root of 2 over 2. So this is essentially negative 1 plus square root of 2 or square root of 2 minus 1. Then yung total area na kailangan natin will of course be given by the sum of these two areas. And that is equal to 2 times square root of 2 minus 2 square units. So I guess nung tinitignan naman natin yung graph, you could have made the observation that yung left region at yung right region, they should have the same area, di ba? At na-verify naman natin nung kinumpute natin separately yung definite integrals nila. So let's box our final answers. Siguro let's just make one final observation na ang 2 square root of 2 minus 2 ay positive. And since we're looking at area values, we expect our answer to be positive. So it's usually nice to do that one quick check kung tama yung sign kasi it might save us from mistakes. I'll cut the video here kasi medyo mahaba na, and I'll just continue the lesson on the next video. So for now, salamat sa pakikinig.